Okay, so those tubes, air filled, all right? Now, one of the things that happens with this middle ear area is it's going to make its way to what we know as the nasopharynx, and it's going to be, like I said, as adults, the tubes, this middle ear, it is going to be a way to help us drain as well as aerate, meaning the air pressure that's in there in the middle ear. And by equalizing the air pressure in the ear, we are able, well, first of all, it helps with hearing, and it's going to help with balance. All right? So if we take a peek at what the picture in your textbook shows, what they're doing here is they're representing the outer ear going to the middle ear, going to the inner ear. So this outer portion goes all the way to our eardrum. Once we get into the bony portions, my middle ear, note a small portion of it. The three smallest bones of the body, okay? Yes, they are counted as bones, and they are the three smallest. We've got our malleus, incus, and stapes. Y'all know all that? Okay. Look at their connection. All right? We see that the eardrum is connected to the malleus, which looks like, and it does, it has an articulation to the incus, which articulates to the stapes, which looks like it's got a connection to what's now going to be a part of my inner ear. And then I've got what they're trying to represent here as this little muscle. Now let's think about this for a second. If sound funnels in, sound, because it is going to be on the air waves, guess what it does against the eardrum?
It bounces?
This tympanic.
It bounces?
Sort of, yeah. Based upon, and like I said, your textbook is going to get very detailed about a lot of this, but the waves that it comes in on, okay, they can change in height, they can change in their distance based upon the sound. Is it loud? Is it soft? Is it high-pitched, low-pitched? That will affect those waves that are coming in, all right? So those waves come in, and they're going to, boom, they have nowhere else to go. The only thing they can do is boom on this tympanic membrane, what we know is the eardrum, and back out, right? Because hopefully that air doesn't get to come this way, all right? Based upon this anatomy that you see right here, if you have those waves coming in, what does it look like it's going to get started? What's going to happen based on the anatomy that you see right here?
Like what steps are about to take place?
Well, just based on what we've got right here.
Do you mind if I look at your skulls? Someone took all of our skulls out of my lab. Or at least most of the skulls out of my lab, so I'd probably just see how many skulls you have. Are you going to need them today?
No, I'm good.
Okay.
Just might want to check the bio lab. They might have gotten them for something.
It's possible.
Yeah.
Possible. Thanks, I'll check them.
So if we think about how that's going to come in, does it look like we're going to get a series of movements started?
Yes.
How? Why?
Because the membrane is going to vibrate. And since it's connected to the malleus, which is connected to the incus, which is connected to the stapes, they're all going to start moving too.
All right, did everybody hear that? See, y'all got the good hearing. Okay?
The ear is like a giant, was it the Rube Goldberg device? Or
What?
what is the machine, not Rube Goldberg, whatever the machine is, a ridiculous, overcomplicated machine that causes something to move. You see it in cartoons, like a bowling ball hits dominoes, and then the dominoes start rolling. Was that Rube
The
Goldberg?
what?
Rube Goldberg.
It's like a series of, it's like a,
Is that how you say it? Rube, like R-U-B-E?
I think it's spelled R-H-U-B. Yeah.
Rube Goldberg.
Yeah.
Okay, I'll look that up. Yes, so what we're going to find is those waves coming in are going to kind of do this bounce to that tympanic membrane, which then begins a movement of those ear ossicles. And those ear ossicles look like they got a connection to my maze. Does everybody kind of notice this maze that's right here? So if I look at this inner ear, it looks like I've got these circles going all around up here, my semicircular ducts. Then I've got the snail, all right, the cochlear duct, all right, and it looks like these bones are going to do some knocking on these structures. And pretty much that's what's going to happen. We're going to see that these structures right here in this inner ear, they're going to be specialized. And the cells that are going to be found there, we're going to be dependent on those cells and the fluids and the structure of these mazes, okay, this labyrinth that's present. We're going to be dependent on that for hearing and then equilibrium. If you look at these two structures, the one that looks like the snail, the one that's the circles, what do you notice about nerve fibers? All right, if I think about my cranial nerves, if you look at that cranial nerve that is exiting from those structures, all right, you happen to remember which nerve that is, not number, what's the name? My vestibulocochlear. Let's take that term apart. Vestibular. A vestibule. Anyone know what that is?
Isn't that like the entryway to your house?
Some people may still, have one of those. When you think of vestibule, it's like an area that you go into before you enter the official structure. So vestibulo and then cochlear. Which part is connected?
I mean, I know a cochlear implant is to help somebody who can't hear.
Okay, the cochlear implant, because when we look at the structures that are listed here, we have the cochlea. And do you see a part of that vestibulocochlear nerve attaching to that area?
Yes.
And when people get those implants, like you were talking, have you ever known someone that has one?
Not personally known, but I see them often enough.
Okay, and when you see them, where is that apparatus connected?
Right
Right
behind
back
the
here. Because they're needing it to be connected to which part of this vestibulocochlear nerve?
The end.
The cochlear. Because my vestibular, a vestibule, something that you go into before you go into the official room, is going to help with my equilibrium. The cochlea is going to be responsible for hearing. So that vestibulocochlear nerve, as it comes in and as it begins to branch, you see the cochlear portion to the cochlea, the vestibular to the vestibular portion. Does that make sense? This is why we now see equilibrium as a special sense. All right, it's one of the reasons we added it. Now,
So is that implant attached to the nerve or the actual like cochlea itself?
I would have to look that up, but I would imagine that that device is what's picking up the waves and turning them into an impulse for the cochlear nerve. But don't quote me on that because I have to look it up, okay? I've only known one person who has it, and I didn't know them well enough to be able to be like, what happened? When did you have that done? Did it hurt? How does it do? What can you hear? I didn't know that way. So, based upon this structure that we have and the anatomy of it is the reason we're going to have the sound and our ability for equilibrium. Overall, the structure's relatively small. We do see that the nerve branches. This inner ear, the internal portion, like I keep saying, a maze, okay, within this bony structure. It's like this huge labyrinth, and we call it the bony labyrinth, and it's got this maze inside of it. Now, once again, your textbook is going to get very detailed about this membrane that's going to be lining it. I'm going to try to keep it simplified for our terms, okay? We're going to see that membranes are going to line these bony, this labyrinth, this maze. We're going to have what's termed perilymph. Lymph means fluid, okay? We're going to come across that again, though, once we get to our immune system. But lymph is letting us know that there's fluid present. Now, the term peri, what does that term mean? Peri means to the outside, all right? So outer portions. So perilymph, and then we're going to have endolymph. Endo meaning what? To the inner, to the inside part. What we end up getting is what we refer to as a tube